Yeah. Okay, just one quick remark. You remember we did this problem, this one. Now, just remember that in this particular problem, the moment is acting in which direction? Only the Z. So this is the moment is acting only in the Z. We covered this problem last time. For those of you who did not attend this class, I urge you, please do watch the recording, because today's content that I will be covering, let me open our today's content. This one, this content is not included in your midterm 2, but you already know the contents included for your midterm 2 on O2 class. This stress transformation equation is not included. Okay, let me just talk about what we covered last time. Again, I will emphasize what we covered last time, which is very important, again, from, I would say, exam perspective as well in general. I will again emphasize that the moment is acting in the Z direction, and then we solve this complete problem. The only reason I'm emphasizing it again and again is because I ended up writing these two formulas. So my only worry is that a student might end up saying one component is mz and one component is my. No, we have not covered such kind of a problem in this course, in which moments are acting in around two different axes, and you have to find the bending stress. I haven't covered it. It's a little more complicated. If time permits, only then I will cover. I will again emphasize that in this particular problem, the moment is acting only about the Z axis, although with a little catch that you have one component as positive and one component as negative. Please remember, in this particular problem, the moment is not acting in the Y direction. You have to watch the recording if you miss the class. Again, it's an important topic for your midterm exam too. What we covered till now is very important. The example that I was just showing you is very important, again, from exam perspective. This particular topic of stress transformation equations is not included in your midterm 2. Of course, it is included in your final exam. So I will start today a new topic. Do you have any questions or reservations for me? And for students who did not attend the last two classes, I urge you, do watch the recording. Do watch the recording. Those topics are very important. Yes.
Would it be better if we practice some questions for the midterm?
I would have in a general scenario, but I do realize I have covered and went over a lot of problems, including a very comprehensive homework assignment. So that's the only reason I don't want to. For example, in longitudinal shear stress, I spend a lot of time, different facet of problems. So you have everything, good homework assignments, a textbook, go over it. This particular problem that I covered is so comprehensive. Look, again, for students who did not attend last class, just to motivate them, I went over the fact that when you try to find the stresses at point A and B, just I will revise it. At point A, the point A lies on the neutral axis. So the bending stress fellow is gone, right? Let me just make some adjustments. Okay, hang on. Okay, the point A does not have bending stress, but I did cover this point that it does have a direct stress, N over A. You can't help the fact that N over A exists, a direct stress. This is the first time we covered like this in our class. Then when we talked about the bending stress at B, students were very comfortable in using My over I formula. The only predicament was that now you have two components of moment, but both the components were about the Z axis. And why is that? Because when you are pulling it, 150 will bend it like this, and the component of 200 will bend it like this. Both the components will bend about the Z axis. So we made this beautiful formula My over I, but students also told me that there is a direct stress component as well, right? There is a direct stress is also acting at this point. Then we did not stop. We said, what about the shear stress? And that goes back to the question you asked in one of the problems, that if this is a T, wouldn't this layer be of interest to us? So we said, let's not stop. What about the longitudinal shear stress? We wrote the formula VQ over IT and VQ over IT. Students told me that B will not have a shear stress, whereas A will have a shear stress, longitudinal shear stress. So please revise these concepts. And on that note, I have to continue.
So can I ask you a quick question?
Why not?
So the thing you're trying to say that when let's say imagine the previous question three-dimensional, right? Let's imagine the three-dimensional, the previous question.
No, if you imagine the three-dimensional that I haven't covered that.
No, but let's say just hypothetically, and there was a force acting like towards in the Z direction.
Then-
would that be we consider it differently, then, right?
Of course.
Is that what you're trying to say?
We haven't covered that.
Then that wouldn't be a moment in Z direction. That would be a different moment.
Okay.
Right?
Just-
Is that what-
I understand the question. Just remember that when I teach you stress is equal to my over I have only covered the moment in only one particular direction, only Z, or in another case, only Y. Never ever I have told you that the force is acting at an angle where the component of moment will be about Z and Y. I haven't done that. That's a advanced topic that we can cover if the time permits. Please let me at this point continue. Do we have any questions or reservations regarding the second midterm? Okay, that brings us to a new topic, stress transformation. What does that mean? You have a wooden stick, both of us are pulling. The wooden stick will break in observation right about around 45, 43 or 42 degrees of angle. This means there are stresses at planes that are of extreme interest to us. We cannot just do a stress is equal to F over A and feel happy about it. This means that I need a complete picture. I am telling you that I'm pulling it like this. But you can ask me that why on earth is this thing breaking at a 45-degree angle? Sorry, like this, like this, like this. Why is it breaking like this? So in order to answer this question, we have to come up with a stress transformation equation in 2 dimensions. I will not get into the derivations. So these expressions will be given to you in an exam setting. And again, I will emphasize that these are 2-dimensional equations because students can immediately ask me a simple question. What if I am also putting a force in the Z direction? Are you getting my point or not? So just imagine if I put a load in the Z direction, let's say this is stress Z, immediately this equation raises its hand. This equation becomes invalid. Got it? I'm talking about only a very simple 2-dimensional stress case. And by the way, if you personally ask me, handling stresses in the 3 dimensions with that little technique is way easier than this one. Anyways, this is not a 434. Stress Y prime is equal to stress. Okay, Marij is joining us. Stress X plus stress Y divided by 2 plus stress X minus stress Y divided by, I'm sorry, this is not plus, divided by 2. Again, expressions minus tau xy sine of 2 theta. Like, trust me, it will be such an easier job if I explain it to you. Everybody would be like, is it so easy? Like, seriously, stress x minus stress y divided by 2 sine 2 theta plus tau xy cos 2 theta. Let me make it neat and clean. Okay, number one thing, what does these 3 expressions mean? Number one, somebody is applying the stresses in 2 dimensions. Either they are pulling it like this, or I don't know, somebody is putting a torsion, whatever. As long as we are talking about 2-dimensional stress scenario, I am allowed to use these expressions. What is the meaning? The meaning is that you have that, you see those yellow lines, one is x prime and you cannot see that, that is y prime, the yellow line. So I have rotated my frame of reference. Somebody said that if that element is subjected to a normal stress of 10 megapascals in stress X and negative 5 megapascals in Y, and the shear stress that it is subjected to is negative 6 megapascals, can you tell me what will be the stresses at a 45-degree angle? Now, there are 2 observations. First observation is that When I gave you a negative value, you see that it's inward. The second observation is it's a negative value of shear stress. How did I accommodate that? Always follow the right face. Yeah, of course, this is a very crude way of explaining, but follow the right face, right and left face, and see the clockwise or anti-clockwise. -6 means my positive x will have a downward that is clockwise. That's why I put a green arrow downward, this upward clockwise, and these two have to be anti-clockwise, and I created this little element. Now I have to find the normal stresses at this and this angle. For those students who are getting confused, what on earth does that even mean? This is what it means. I put a stress like this and this, and shear stress is also available. So what I'm doing is I'm trying to see what will be the stresses. So why don't you rotate with me at 45 and just help me? Tell me whether I'm right or wrong. Is it 45? It's 45. So now you have to tell me the normal stresses in this new normal and shear stresses in this new element that is tilted 45 degree. Clear? Yes or no? Not clear? Now it will become clear. Use the calculator. Give me the value of stress x prime, stress y prime, and tau xy prime. It will become immediately clear. You see, you need to understand. I have a stick. Both of us were pulling. This stick broke like this at a 45 degree angle. It hits me that there are different planes in an object that may be of interest to me. So that's why I want to find the stresses at different planes. Since nobody is doing it, then I will do it. Minus 3.5. Okay. No, Abu is doing it actually. So you can confirm with me, Abu, if you're getting the same answers, because these answers were also given to me by my students. Now, why don't you make the element with me? Let's do it together. 1 minute. 45 degree, right? So anti-clockwise, turn it anti-clockwise. Huh.
If you turn like that way in
Clockwise.
clockwise 45.
No, that is minus 45. I am turning anti-clockwise. Positive 45.
So it will be coinciding with the x prime and y prime, right?
Huh.
The
Yes.
x and y will
Good.
coincide.
Yes, thank you. In fact, you made my life easy. I was getting confused. Thank you. So it will be one line here, one line here, one line here, one line here. Okay, and why don't we play this little game? Let's put a little dot here. So it becomes little dot here. Now it's correct? Huh? Okay, then let's play the little game again. This is your plane, right? Did you get minus 7.5? So focus on this plane. Focus on this plane. Negative means clockwise, nahin? Clockwise. So focus on clockwise. So clockwise, and this will be anti-clockwise. What will be the value? Focus here, minus 7.5. So I will just write 7.5 megapascals. And there are students who are saying, why did you write 7.5? Of course, I already put a clockwise and anti-clockwise here. Still, if you don't like it, you are allowed to put a negative. Then I will put a positive, minus 3.5 megapascal. So this was your X. What will this be? As Mehmet said, this is my x prime, and this is my y prime. Okay. So this one become, let me use a yellow color, minus 3.5 megapascal. Boom. Boom. And I will put nice and beautiful at minus 3.5 megapascal. Inward. Okay. Last but not least, I will put a light blue color, positive 8.5 megapascal. Positive means outward. Boom. Boom. Okay. Is it clear or not? Huh? The only confusing part is tau x prime y prime. Tau x prime y prime was negative. So confusing. When you are about to put the arrows, how would you know that I have to put like this or this in that tilted square? My only suggestion to you is follow this. This is your plane. A clockwise or negative value means arrow will be downward here and upward here. Similarly, if you are getting a negative value here, when you are tilting it positive 45 degree, this dot appears here. Put a clockwise on this surface to emphasize the negative value. Okay, I'm stopping here for 2 minutes. Absorb it. Focus and tell me if it's clear or not.
Good.
Mhm.
So, therefore, for example, if we pull like this, 10 megapascal, and also there's compression in top and bottom side. So,
And then there is a shear as well.
and there's a shear as well. Like,
Whatever shear, okay, then.
is the shear result of this shearing force?
Shear is actually a result of how you are applying the loading. So in a general object, for example, I might have put a load like this, but if you make a section at an angle on surfaces, you will get shear. So for example, even if you're putting a load like this and you're saying I'm not putting any shear, if you take an element at an angle, there will be shear. In fact, if you have a stick and you pull together, it breaks at 45 degree angle because of the maximum shear stress at 45 degree. What is your question?
Oh, okay.
Is it
I
straightforward?
understand right now, okay.
Huh?
I understand right now.
So can I ask something?
No, why not?
Why did we change the direction of the shear stresses? I didn't understand.
I did not change. So for example,
No,
it is,
like 6 megapascal is like, let's say, on the right side is downwards, right?
so I said downward.
Without an angle, but then we calculated it as 7.5 megapascal.
So because the question was you have to find it at 45 degree angle.
Yeah, but why did they change direction? That's what I'm asking.
I did not change. So
No, let's say on the top it's to the left, now it's to the right, like.
where, here,
Yeah,
this one,
yes.
because I tilted it to 45 degree like this. Look,
Uh-huh.
45 degree. I tilted it and I have to forget this one from now onwards. This is my new element. I tilted at 45 degree and now the answer is negative 7.5. I will focus on this surface only first and I will put a downward arrow here, upward arrow here for clockwise to indicate negative 7.5 and subsequently anti-clockwise here. And if you are asking me the question why we are focusing on this surface, because we always focus on the theta equal to 0 surface, you tilt this surface becomes this surface, then I started focusing here.
I have a question about the minus sign part. We say minus 6 megapascal. So how could we decide that?
Nice. Somebody gave me that the object is subjected to these stresses. Give me the stresses at 45 degree angle. I did not tell you. I did not find.
In diagram, how could we draw it?
I will tell you. I will tell you.
If say.
I'm about to. At what I'm saying is, at the surface where you have the x-axis, put the arrow downward if you have a negative shear stress. Put the arrow upward if you have a positive shear stress. That's the only trick. Okay, give me another question. Theta equal to 120 degree. Give me the stress x prime, stress y prime, and tau x y prime. Quickly.
Could you previous slide?
I will. Theta equal to 120 degree on calculator. I have to finish this hybrid thing and then we would have this bonus 2 points, do it. But now I cannot do it. Give me one only, stress x prime, okay. Give me at least one.
Jump 3.95.
Okay, good. So student has told us 3.95 megapascal. And then we have positive 9.5 megapascal. And then we have tau x prime y prime 1.05 megapascal. How many students agree? Now at theta 120-degree angle, okay, make the element on your pieces of paper. This is not straightforward. You have to use the imagination quickly. Y, x, make x prime, y prime. So how would you do it? I will help you. This is your original, let's say, element. Okay, I did a horrible job of why my y-axis is so bad. Oh, kidhar gaya? Hang on. Okay, laptop stuck. Did anyone make it? Did? Okay, this is my y-axis, let's say. This is my y-axis. Okay, so let's say this is my y-axis. Okay, the students who have already made it, let's see if they are getting the same thing as me. Theta equal to 120 means that this line will become somewhat like this. Let's say, I don't know, like this, right? Somewhat like this, 120. I think 120 is like this. And then I will have a 90-degree, and then I have another 90-degree. I'm doing a horrible job, but I think you will understand somewhat like this. Again, these are 90 degrees to each other. So now I will play this little game one more time. Tau x prime, y prime came out to be, I'm sorry, these values are wrong. Sorry. I apologize, everyone. Stress y prime is 1.05 megapascal. Please spare me. Bear with me. This one is tau x prime y prime in my notes is positive 9.5 megapascal. Sorry for the mistake. Okay, now let's play this little game. Can anyone double check the tau x prime y prime, by the way? No, I double checked. Sorry, I double checked. So my original question had value of tau xy minus 6 megapascal. So let me mark this. Now this one will become this one, right? By the way, my notes are wrong, I suppose. Anyways, so if this value is coming out to be positive, then I suppose I will have to put a positive here, and this one will be clockwise. And then last but not least, stress x prime means 3.95 megapascal positive, and positive value of 1.05 means 9. 1 minute. This one becomes 30 है. 30 है. Sorry. Thank you. Thank you. Excellent answer from him. He is right, actually. This will tilt only 30 degrees. Sorry.
On the top surface.
Top surface, right? This one. Why don't you double check with me? 120 will be This line will become this in 120, no? I think he's right. Nine.
90 degree, 30 degree, it's going to be on this side. So
Huh?
it's going to be on the opposite side and then you first line, the opposite side.
This one,
No, the other.
this one.
Oh, yeah.
Look, 90, 30, it's going to be,
Yeah, I think so, yeah.
Hocam, it's going to be on that side.
No, if you turn.
Look, look.
Yeah,
But
he-
if
he's
you
right.
turn 90 degrees,
एक minute, 1 minute. I think, okay, this will be X prime. I don't know. Why don't you take another? I think this will be X prime. This is X. I'm pretty sure. Look, even Ahmed, this X becomes 90 and then 30. So X becomes X prime. You see, this arrow becomes 90 when it goes here. And with another 30, 90 plus 30, this becomes 120. Now it's correct.
Same thing, but from the other side.
And this will be Y prime. Yeah, thank you, everyone.
Yeah, yes.
Got it. I ended up making a rather complicated drawing. Okay, now follow me. We have tau x prime y prime as a positive value. Okay, now I will put anti-clockwise for the positive surface. If this is anti-clockwise, then this will be clockwise. Now I understand that my notes were not wrong. Now I will play this little game along with you. What is the value of stress x prime? 3.95 megapascal. So let's make a nice purple color. 3 point. Thank you. By the way, we had a couple of students who told me that I was wrong. Thank you. 3.95 megapascal. I appreciate it so much. Stress y prime is 1.05 megapascal, again in the positive. Let me use a nice, which color? Red. And again, red color is confusing because axis is red. Okay. And this value is 1.05 megapascal. Is it clear or not? Look at the x-axis. Clockwise, negative shear stress means downward arrow clockwise. Similarly for x prime, look at that x prime surface and decide if the shear stress is clockwise or anti-clockwise. Clockwise means downward, anti-clockwise means upward.
Sir, can you please explain the blue arrow?
Huh?
The blue arrow.
So for example, stress x prime. I first made the x prime, right? Everyone said that the x prime will be that surface. When I have that surface, I followed this one. Tau x prime, y prime is positive 9.5 megapascal. Positive means that you look at the x prime and draw the arrow in an anti-clockwise fashion. So I drew the arrow like this for an anti-clockwise fashion. And the rest of the surface will have clockwise fashion. Positive means anti-clockwise, negative means clockwise. On which surface? On x or x prime. That's it. Okay. Okay, well, this topic was supposed to be easy, by the way. Huh? I'm not sure why it became complicated. He is not sure. You're not sure?
Let me ask you. Welcome.
Look, what I'm saying is when you have tilted, just identify the x prime. Let's say you have identified x prime exactly like everyone helped us. Let's say this is x prime. What I'm saying is if someone has given you tau x prime, y prime, a positive value, then on this surface you try to make an arrow in the anti-clockwise sense. If someone has given you a tau x prime, y prime negative, then you make the arrow sense in the clockwise sense, and for the rest of the two surfaces, it has to be opposite to this. If right now this is anti-clockwise, this will be can't help it because of the static equilibrium. So my only point is always focus on the x prime surface and subsequently go for positive or negative. Now you can discuss, and then if you're still not clear. Okay. Let's pace ourselves. Just tell me with a yes or a no quickly. Whatever I have gone over here, is it applicable or not? Is it applicable or not?
No.
No, good. Not applicable. Remember the limitation. There is something called rotation of matrices. It's very easy. We could have covered it in this class, but it's not covered in 206. So I will skip it. For even 3 dimensions, you can actually easily rotate using matrices. But it's something that somebody can think about themselves, not included in right now, at least not
So in this particular example,
this one.
yeah, this one, in 3 dimensions.
Uh-huh.
So we're taking the cell as a cube or different kind of.
This is a whatever object is, the point is stress is acting in X, Y, and Z directions. The formulas I showed you does not have Z.
No, but for example, in the previous one, we tilted the square, right?
Huh.
For this question,
Huh.
we're tilting the cube, right? For example.
Nahin, exactly. So I will have now, I need to have now this element, another element, X, Y, X, Z, Y, Z, 3 squares, and I will think about
By
them.
the way, in the real application, there's no tilting, right? We are just finding the stresses on different angled layers on the object. So in real life, we don't tilt them.
No, we are not tilting the actual object, although the load can be at an angle, of course. So for example, if the load, let's say it's at an angle, then we have already gone through, load is acting at an angle, there can be bending, there would be bending. Number 2, there can be longitudinal shear stresses, of course. Then what you will do is, you will say stress X because of bending, stress Y, whatever, longitudinal shear stress value is this. So you will get all the required stresses, correct? X, Y, tau X. Now that you have got all the required values, although your load is acting at an angle, remember, but you have got stress X, tau XY stress. Now you will start cutting these imaginary layers of interest and you will see the, acha, okay. Everyone, how many, okay, we had a couple of students who were today discussing eigenvalues and eigenvectors, right? Both of you were discussing eigenvalues and eigenvectors, correct? I think they were discussing in the beginning of the class. So I will tell you some application of eigenvalues and eigenvector. Okay, before I go over that advanced stuff, let's talk about something simple. We will not get into derivation, but I will go over a couple of formulas and try to explain to you what is the meaning. Minus stress X minus stress Y over 2 square plus tau XY square. What is the meaning? Number 1, this means 1 means max, 2 means min. Okay, then we have tan of 2 theta p is equal to 2 tau XY over stress X minus stress Y. And then we have tau max is equal to stress X minus stress Y. What happened? Divided by 2 square plus tau XY square and tan 2 theta S. Again, formulas I always give in the exam, as you know. How many students agree? Stress X minus stress Y over 2 tau XY. What are the meaning of these? Number 1, principal stresses means maximum and minimum stresses. Maximum and minimum, pardon me, maximum and minimum normal stresses. Principal stresses means maximum and minimum normal stresses. Principal planes mean, you cannot see this, hang on. Principal planes mean at a plane where they exist. Okay. Maximum shear stress means maximum shear stress. theta S will give you that plane on which that maximum shear stress happens. We take this, we pull this wooden stick, it breaks like this at a 45 degree. 45 degree. Why it's breaking at 45 degree? Although I'm putting a load like this, because there are planes that are very much vulnerable. What are those planes? They exist at 45 degree. Why 45 degree? Because maximum shear stress actually happens there. So using these formulas, if I give you a simple stress problem, you will be able to tell me where the maximum normal stress happens, on which plane, at which plane does minimum normal stress happens, at which plane does maximum shear stress happens. Yeah, that's pretty much it. Confusing or clear?
The difference between tangent 2 theta P and the 2 theta S. What is the difference?
Okay.
Tangent theta P.
Theta P means the angle of the principal plane. Theta S means the angle of the maximum shear plane.
So they are just vertical to each other.
Oh, good. How did you mean 90 degree to each other?
Yeah.
How did you figure? You are 100% right, because
Yeah,
they are 90 degree to each other. I'm not sure how did you figure so quickly.
Both and you get minus.
Huh?
Yeah.
Multiply both, you get minus.
Okay. And then you take so nahin, they act at not 90 degree, they act at half, they act at 1 minute. This is the maximum shear stress, this is the maximum normal stress. The maximum shear stress will act at 45 degree. I'm sorry, it will act at 45 degree. I will even prove to you in few seconds. But you were very close. 45 degrees, sorry, not 90 degree. I will explain everything. Just hang in there with me. Look, number one, now I will give you stress X value and stress Y value, and I will give you tau XY. I will ask you, give me the maximum normal stress or minimum normal stress, you will give me. I will ask you, give me the angle of principal plane where they exist, the maximum or the minimum, the principal stresses as I call them, you will give me that. I will ask you, give me the maximum shear stress, you will give me that. I will ask you, give me the angle, the plane on which they occur. So let me give you a problem and you do it. By the way, it looks very straightforward, trust me.
So can you just go back to the.
I will write down 45 degree. In fact, let's it's very it's very straightforward to even understand the 45 degree.
Then we do this in the beginning of the semester.
What?
This concept.
Oh,
Where
I used to, yeah, I did talk about, I did talk about 20-25 minutes. I know. I did, good. I did talk about 25 minutes, but now you have the comprehensive topic. When you're done, you will let me know, huh? 45 degrees, sorry. I will talk about in more detail. Not 90, 45. What does that 1, 2 mean? They are principal stresses. Principal stresses means maximum normal or minimum normal.
P was.
P, theta P. P means principal, theta P here means finding the principal plane. You're talking about where does the principal plane lie? What is principal plane on which the principal stress would lie? By the way, how many theta P will you get from this formula? When you take a tan inverse, how many possible values? 2. On one you will have the maximum, on the other you will have the minimum. Okay. Okay, on that note, it's very confusing unless I help you with a problem. So do this problem, everyone. Please do not think that it's simple calculator things, or we will not do. Do it, please. So this is a problem, 10 megapascal. Okay. Then somebody gave me a 50 megapascal. Okay. Then somebody gave me a 50 megapascal. Okay, I'm not going to bother to write. You understand that this is also 10, that is also 50. Then somebody said 40 megapascal positive shear. That means it will be anti-clockwise. This one will be clockwise. Why am I? What happens to my screen today? Acha. This value is 40 megapascal. Boom! Give me stress 1, 2. So give me stress 1 value, which is max. Then give me stress 2, which is stress min. Then give me tau max. Do you want me to go back? Huh? Should I show the formula? Anyone? Okay, take a picture or whatever. Okay, I don't think 90% of you are even doing it, but that's fine. Oh, that's fine. I'm also observing, but it's entirely a personal choice. Oh. Huh?
17 minus 30.
Good. He did the right answer. One more student, Bahadur also got it. Ghazal as well. Okay, I think 2-3 students have got it, so I will proceed. One of the students said stress max is 70. He also said that stress min is yes. Yes.
For maximum, it will be 70.
70. And minimum it will be minus 30.
Yeah.
Okay. Now I have a question. Give me the tau max. Good. 50. Again, our students correctly did it. Here comes the most important question. Give me the value of theta p. Give me the value of theta p.
John, 26 point.
Okay. Anyone else who did it? Very good. Your answer is correct, by the way. You also, Hafad also got it. Okay. 26.6. Okay. Here comes the question for you. 90? Nine. The other angle will be 90 plus, by the way. Okay, hang on. I have a quick question for you. 1 theta p is 26.6. the other theta P will be 90 plus 26.6, 116.6. My question to you is 70 lies on this one or 70 lies on this one?
Hocam,
By the way, the question is not done yet. I know it's very confusing. I will tilt the element. I will explain again. So relax. This is going to be a tricky problem. Just bear with me. Yes.
you know, what is this principal planes like?
Where the principal stress lie?
The principal stress and principal planes like
Principal stress means the maximum or the minimum normal stress.
in the bar, right?
In the bar, I need to use a knife to cut it at a particular angle. Which angle? Theta P. At that angle, I will find maximum normal stress or minimum normal stress for that matter. Acha, tell me quickly, 70 lies here or 70 lies there?
The more.
No, but it's how, probably you are right, but I cannot figure. There has to be a process. So, you know, what I used to do back in my days, I will just tell you that. You remember you use this formula? You know, personally, I just hate this formula for some reason. I used to love this formula. So you know what you do? You take this formula of stress x prime and you just put the value of theta P inside this one and put the value of stress x, stress y and tau xy that they provided you. Follow me. The stress x prime that you will get will be the principal stress. And that principal stress will correspond to the theta P. Automatically, the other that you have found will be for the other one. So let's play this little game. Stress x prime. So students now are like, why did we even bother to calculate this? I understand your concern. So back in my day, I never used to even use the formulas. I used to use the main formula plus stress x minus stress y divided by 2. What was the formula, by the way? Cosine 2 theta plus xy. Acha. Why don't you put a theta P equal to 26.6 here and now give me the value of stress x prime. Yes, sir.
Using this formula that we have for, let's say for maximum, and then 75.
Mistake. Whatever answer I wrote there, this is correct. But what is
I'm using that version.
that's one stress, one stress.
So this here is
This is not, this is not 50. How did you minus 10?
because there's stress in the x direction.
Nice. That is negative 10. That is negative 10. It is acting compressive. That is a negative 10. So
What about the other?
that is positive 50.
No, but it's in like the opposite of 10. There's negative 10, yes, but there's
That's
also.
fine. It's inward. Inward means negative, so you have a 50 minus 50. That is the mistake. Huh?
It will be shear max.
What shear max? Give
It
me,
will be 89.9, but it will be turns to 7.
give me whether it is 70 or somebody replied. Could we achieve two answers? 70 and minus 30 from one equation. Oh yeah, you can. I will talk about it later. Give me the value of stress x prime. Who got it? Bahadur or Ghazal? Both of them. And Ahmed as well. Sorry, Mehmet as well. 70 megapascal. So this means it happens at theta P equal to 26.6 degree. Then you can again do this for the value of theta P at 116.6. Of course, it will be a waste of time because it is pretty obvious that now I will have the 30 megapascal at minus 30. I apologize. At anyone? Boom, 116. And how many students agree that instead of this stress x prime, what should I write? Stress 1. And how many agree I should write For minimum, 2. 2 means minimum. So maximum stress is 70 megapascal at 26. Now it's very confusing. What on earth is theta B? I'm about to tell you in 3 minutes. Okay, let me answer Marriage's question. Marriage asks us, how to see chat? Chat. Could we achieve 2 answers, 70 and minus 30 from one equation? We can. So,
On the first equation.
1 minute. Marriage, I will talk about it later if it's fine, huh? In 10-15 minutes or 30 minutes.
Question?
Mhm.
How could we find theta p equals 160?
I added 90. I added 90 to theta p.
Why would you?
I am about to answer this question now. I'm about to answer this question right now without any delay. Okay. 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 Now,
Because of this, right, Hujam?
huh?
For example, this theta p with respect to the x-axis, and therefore when we adding 90 degree, this will be like
Exactly.
this.
This is the reason.
When
This is
we
the reason.
Following the direction.
This is the reason. Okay. In the stress y prime at theta p equal to 116, you will also get stress 2 equal to negative. I apologize. Sorry. Stress y prime at theta p equal to 26.6 degree. You will again get stress 2 at minus 30. But anyways, you have already found this. Now, how do we make all of this? So what we do is, let's make, I think we need to go to a break, by the way. So let me just finish this and we will immediately get into a break. So let us make the element first. We have 2 chat messages. First is, okay, now why don't you all help me? So tell me, where is 26.6 degree anti-clockwise? So 26.6 degree will be something like this. Why don't you tell me whether I am right or wrong? This will be 26.6. This will be 26.6. This will be. This will be. This will be. This will be like this. Correct? This will be. Bear with me, please. Bear with me. I know we have to go to a break, but bear with me. 26.6 degree. Now play this little game with me. It was like this, it became like this. So where will be the stress x prime? 70 megapascal. Boom. $70 megapascal. Correct? What about stress 2? Minus 30 megapascal. Hussain, it's inward, compressive, right? Compressive. Abu, it's fine, right? Okay, minus 30 megapascals. Why don't you tell me at what angle is this minus 30 happening? What angle? 90 plus 116. What you just calculated. Boom. Everything is fine. Okay, now I think we have calculated everything. Now I have a very critical question. What is the shear stress on this surface? Abdullah and Hafad, you have to focus here. This is a very critical question. What is the shear stress on these surfaces?
Maximum shear stress.
No. Can we find it? We can, right? How? Tau x prime y prime equal to So use this formula. I already know the value, by the way. I already know the value. I want you to do it because I really want you to spend some time and then see that the answer will come out to be 0. So minus stress x minus stress y over 2 minus stress x minus stress y over 2. What was that sign?
2 theta
Then
plus 2 txy cos 2 theta plus plus x.
bus. That's it.
Sir, 2 नहीं आएगा।
ये नहीं
ये
bus.
Yes.
Okay. Okay. What value will you put here? You will put here theta p. Okay. Tell me any theta p, 26.6 or 116, and tell me whether you are getting a 0 or not. Very important. Has to be 0, by the way. I already know it. It has to be 0. Can't help it.
Why?
Look. Will how to answer this? Why? Look, the maximum normal stresses in an object on a plane, they happen on the principal plane. The principal plane will have 0 shear stress. And yeah, okay. Look. Why exactly why?
0.0000.
What video I can check it out later on?
Okay. So, excellent.
Hocam,
Can we come up with a possible explanation for this?
hocam,
I will say-
minus 0.5.
नहीं 0. How far? 0.
Hocam now, where is the
Sir, because
0 है ना?
here
Hocam, where is the
value
shear
of
stress?
stress.
There is no shear stress.
ये क्या
0.
नहीं आ रहा।
Shear stress is 0.
On the principal plane.
Hocam, what was tall XY in our question?
It is given.
I couldn't remember, so I write tall legs.
नहीं, tau xy is given.
Okay, that's
40 megapascal. Hafad and Abdullah, you put 40, right?
Yes, 40.
You get a 0?
Yes.
Okay.
So,
For the principal planes, you will not have any shear stress whatsoever. They will be devoid of any shear stress. So actually, when I am making this particular plane, there is a maximum normal stress, just maximum normal stress. And now if I have to design this structure, I kept on talking about, for example, I'm putting a load of, I don't know, 5 kilonewton. My stress is equal to P over A. And then I used to say, what will be the yield stress of this object? And am I below the yield stress value? And I was feeling happy about myself. Turns out that there are planes that exist on it that will have actually a normal stress, possibly way larger than what I am exhibiting this to. And what is the possible explanation? You see, I subjected this to 50 megapascals and 10. But what is the maximum? 70. You get my point. Now, how to answer? You said why shear stress? Definitely there has to be a physical explanation, but for the physical explanation, right, I'm not sure.
Do you remember the first time that you talked about angled brakes?
No, that reason is different. So for that, for example, the reason is that when you are putting a load like this, so technically, if you ask me that you are putting a load like this, then on this object, what is the principal stress? My answer to you will be, the stress that you are applying is the principal stress. Why? Because there is no shear stress that I am applying this to at this angle. We will talk about it more, Ahmed. But is this clear? I don't know. We will go for a 5-minute break. I think once you come back fresh, we can start. But if you leave, you just remember one thing. Principal stress means maximum normal or minimum normal. On principal planes, we don't have any shear stress. You can double check. I make the element, I put a 70 and a negative 30, but you see, I did not make any anti-clockwise or clockwise arrow. Absolutely not, because there is no shear stress. Break.
Sir, we didn't use this formula 10 to theta as is equal to. the
We will
one-
use it. No, after your break, we will use it, no? It will take a lot of time. Break. Yeah. 45 please. 45.
So for example, in this particular example, the principal plane will be this, and another principal plane will be this one.
One is this, one is that.
One is this, and one of them is that. Okay. Right. Hocam, could you change the time of today's date to tomorrow? hocam?
I can, but when would I even post the solution? Okay, I will do it.
Yeah, if you do that, hocam, it will be very nice because we have a busy.
Till when tomorrow? Tomorrow till when?
Yeah, same with the
11:55.
another great homework.
11:55.
Yeah, hocam.
Okay, I will do it.
If you do that, it will be
Okay,
very nice.
did you see your midterm exam one score?
No, yeah, that's why.
Right after the class, I can show the example to you, okay?
Okay, thank you.
And what is your name?
Kumsa,
Say that one more time.
Kumsa,
Kumsar.
yes.
Did I say it right?
Yes.
Okay,
correct.
okay, see you after the class.
Okay.
This was supposed to be an easy topic, I think. I don't know. Became a little difficult. This was easy, no?
The shear stress direction is very confusing.
No, shear stress is zero
Yeah,
here.
but not here, but like generally, like.
Look at the x or x prime. If you have a shear stress
So
positive,
first of
arrow
all,
up.
we consider the given angle anti-clockwise, anti-clockwise, right?
Positive means that
Like
you need to
this-
have anti-clockwise and negative means clockwise.
Yeah. So when let's say from the square like this, when the shear stress is like this, oh, this is the top, this is the right, and they are pointing this way. So is this positive shear stress?
Just focus on the x surface.
The
X or x prime, if x or x prime is giving an anti-clockwise kind of a direction, that is positive. And if x or x prime is giving a clockwise kind of a feeling, that is negative.
surface,
Is giving an anti-clockwise feeling or not?
anti-clockwise feeling.
That is up, that is upward.
But what if it's at an angle?
That's what I'm saying. Anti-clockwise feeling or clockwise feeling. If it is, for example, your x prime is here,
Okay, let's
this surface, and the arrow is in this direction, that will give an anti-clockwise feeling. This is anti-clockwise, right?
so here, let's say from here, we set the x surface. So is this the x surface?
There is no x surface here. There is x prime surface. So focus on x prime.
X prime surface, this is x prime.
This is x prime. You have made x prime.
Yeah, but x prime is this.
Right, this is x prime. You have written x prime. Okay. So this is x prime. The arrow is in this direction, right?
Mhm.
So
It's clockwise.
so this has to be a negative 7.5 megapascal. Tell me whether I got negative 7.5. I show that.
Yes.
Exactly. So I'm saying look at the x prime or x and see the feel of clockwise or anti-clockwise.
Gupta.
हाँ
While I was thinking about, I had an explanation sort of thing came to my mind.
हाँ हाँ
Since this principal plane has maximum normal stress, we found it by taking the angle and then taking the components of the our first initial forces on the angle, right?
हाँ हाँ हाँ
So if the normal force is the maximum, then should mean that the vertical forces of the two components are equal to each other and the opposite inside, so they actually take each other out, and thus there is no force and thus there is no stress. Can we think it like this?
we actually can. You know why? Because even if for example I subject, as I said, I am subjecting this to this very simple normal stress. Now both of us know that if I am putting a 2 megapascal of normal stress, right? Then what exact value will I have? I will have a stress x equal to 2 megapascal, correct? Stress y equal to 0. Okay. What about shear stress? Right now, just imagine I'm talking about exactly this square cube, okay, when I'm putting a load. So stress y equal to 0, tau x y equal to 0, because you can imagine if I'm putting a load like this and I'm actually taking a cube of this shape as well, then the shear stress is also 0 technically. So technically, 2 megapascal applying like this has what principal stress? Stress 1 equal to stress x. 2 megapascal, stress 2 equal to 0, and tau xy equal to tau xy equal to 0. Now you can actually find the maximum shear stress plane, and remember stress x equal to 2 and stress y equal to 0 and tau xy equal to 0. Just remember this. So go back and look at this. I said stress x equal to 2. I said stress y equal to 0. I said tau xy equal to 0. So something over 0 will give me infinity. 2 theta s will be tan inverse of infinity. Tan inverse of infinity is 90. 2 theta s equal to 90. Theta s will be 45. If we have a wooden stick and we keep pulling it, it actually breaks between 42 to 45 degree angle, because of course that is not a 100% homogeneous material, it has fibers. So technically that 42 to 43 degree that you are getting is because of this that when it breaks at 45 degree, it breaks because of the fact that it breaks on a maximum shear plane. As we were feeling very confident that we have made that wooden stick in such a fashion that it might sustain this load that we are putting. It chooses to break at a 45 degree plane, which is your maximum. So it is possible that your object can break on the maximum shear plane. It is also possible that it can, you never know, it could select the principal plane, the plane which has the maximum normal stress. But yeah, you can think about like that, and at the end of the day, it's force components. So for your principal normal stress, the planes, you don't have shear stress. Yeah, but there is another catch to it. The plane that has the maximum shear stress, does it have normal stress? Yeah, it will have. We will talk about it, but you can figure it out that exactly as we are talking about, let's say the component of forces that will have a little low normal stress than you would expect in terms of the maximum principal stress, let's say. So we will see that as well, but you're doing a fine job in terms
I
of.
guess I understand. Like,
Really?
in my head, yeah.
As long as you are, I'm happy. Oh God, this is a tough topic, I suppose. Yeah, student who is trying to enter into the classroom. Okay. Okay, now give me the tau x prime y prime was not given by our students. Okay, give it to me, please. Tau x prime y prime. Quickly. Up to you have come from break. Everyone is fresh. Why don't you give me tau x prime y prime? No. Sorry, tau x prime y prime. I mean tau max. I apologize. Sorry. Give me. You got it. Tau max. Did we find tau max? When? Blue one on the. Very good. He's right. Tau max is equal to 50 megapascal. Give me the theta s.
No, what is theta?
The plane on which the maximum shear stress happens. Theta s. The plane on which the maximum shear stress happens. Give me the value theta s. Double check and then tell me. Minus 83.
Minus 18 point.
Minus 18 point. Acha. Well, the answer is correct. Boom. Minus 18.4. Okay, life is beautiful. Now, why don't we play another little game? Why don't you do this? Again, this is, you're just double checking. I know that everyone will be like, why on earth you keep asking us to use the transformation equations? I know that it can annoy anyone. Why don't you now put here, substitute theta s and minus 18.4 and then tell me that you are indeed getting this. But double check. I'm getting the point. It's a transformation equation. You either use the direct maximum stress equation or you use the transformation.
This transformation equation is valid for fluids?
For?
Fluids.
No. This one definitely not. For fluids, it's continuum mechanics. That is super hot stuff. Honestly, I don't know from the top of my head. That's advanced fluids. You have to look into it.
So, find the theta s. Using
The theta s equation can show the 2 theta s equal to something.
for the shear x minus space and shear y, right? So using the normal.
Yeah, we are using the given fellows.
Given fellows, right?
Yeah.
Not using 17.
The one that we have found, we are not using it. We are using the given quantities.
Given
Anyone who can tell me 50? No, nobody is double checking. Okay. You got it? Acha, okay. Positive 50. Everyone got it. Okay, life is beautiful. Now, why don't you do one thing for me? Why don't you all tilt this? At what angle? Minus 18.4. Boom. We will have to put a clockwise. Correct? This will be. Correct? Students who are saying, how do you do it? I will save this and I will say, this is how I do it. This is my center. And I am going at what angle? No, 1 minute. Did I make it correctly, by the way? Oh yeah, I am going clockwise. Now, what is this angle? That is theta s equal to minus 18.4 that our students have told me. Then I will play this little game. What is that game? What is the value you got? Positive 50. Now I will answer Hussein's question. That is your positive value. You will focus on your x prime, which is this plane, and you will make upward arrow in the anti-clockwise sense, okay? Anti-clockwise sense, then this will be clockwise. Okay, now one last question for all of you. What will be the principal stresses over this? Any student?
Zero.
Nahin. Not principal. I formulated the question incorrectly. Please pardon me. I meant, sorry, normal stresses. Why would I talk about principal stresses? I'm sorry. I meant normal stresses. Principal stresses on planes which they lie, they don't have any shear stress. The plane on which I have maximum shear stress, please give me the normal stress, not principal stress, pardon me. Give me the normal stress. Now, you can find it by stress x prime equal to stress x plus stress y divided by the way, I'm coming to your desk. I need to see all of you doing it because trust me, there is a reason I am so much emphasizing.
Prime plus one.
Yeah?
Stress x prime.
20? You already did it. Good. Your value is right, but I want everyone to do it, so I will wait. Very nice, by the way. Good. Stress x minus stress y over 2 cos 2 theta plus tau xy sine 2 theta. Now also give me stress y prime, okay? Stress y by 2 the plus, okay, I don't have good memory now. Minus, फिर minus, फिर minus. Correct? Double check. Okay, stress x prime is $20. Hafad, can you also, and Ghazal, can you double check stress y prime for me?
Yes.
Ghazal will do it. Stress y prime. And Abu as well. And all of you. Please, you also stress y prime. So how would you do it? You have to see the values of stress and x and stress y from the previous slide, by the way. And tau xy from the previous slide, not these 70 and minus 20. These are not stresses and stress y. I meant normal stress. So why would I talk? Value? Wait, 20. 20. 20. You are getting again 20, na? Okay, he's again. What about Abu, Ghazal, anyone else? Bahadur? We will wait for them.
Yes, 20.
Okay, 20. Everyone is getting 20. Then what will you do? You will take some marker. Let's say purple is a nice color. And then you will do 20. 20 outward, of course, positive tension. 20. 20. Boom. I'm coming. Did you ask me question?
I got minus 30 for stress y prime.
Some mistake. I'm coming to your desk. I'm coming to your desk right now.
What is the angle that we need to use?
Minus 18.
Minus 18.4. Okay, so this was your original element. What was it? 50? Can you double check with me?
Yes.
Okay, 50. Okay, then What was this fellow? 10?
10 in compression hocam.
ठीक हो गया. Yes. 10,
Clockwise direction hocam. In tall x1.
50. Okay. Then you have, let me use a nice, beautiful purple color. Anti-clockwise 40.
Yeah, and clockwise.
Okay, I'm definitely not writing. This is clockwise. Okay. Now this gives you a nice, beautiful picture. Somebody was putting a load like that. You understood that you have, where is it? There's so much stuff written. Maximum shear stress of 50 megapascal happens at this plane. This definitely is your plane that you might want to be careful about. Then you have a normal stress, principal stresses of 70 and negative 30 megapascal. You may want to be careful about the 70 fellow, let's say. Now this is a decent stress picture that you have got today.
Can I ask something
Uh,
about the green arrow? You told that the green arrow should be anti-clockwise to the x.
did I make a mistake now? Go ahead. What is the top? What is the top?
Okay, yeah.
Nine?
Yeah, correct.
I don't know.
Confuse myself with x bar and okay, there.
You have to explain to me what is happening. What about Tom Max? Tom Max was 50, right? Huh?
Yes.
So this is 50, correct?
Yes, it is.
Achha, so let's put 50 now. Let's put this 50. I think you are rightly confused. This is 50. Okay. And this is 50. Subsequently 50, 50, 50. Okay, I think I discussed this with one student, but just so that all of you are with me on this, I want you to do this problem. I discussed with you in the break, by the way. So you already know it. But for the rest of the class, I want you to do this. In fact, why are we making cubes, and why don't we make a stick like this? Okay. Do this question for this solid stick. Let's say you have, okay, tell me the value, 2 megapascal and 2 megapascal. Okay. Give me the do it. Do it. Do it. Do it.
Could you open the first slide? Take the photo of the first slide. And what is it? Try this one.
Take a picture, everyone. Okay, ठीक हो गया. Now, also tell me theta s. I'm sorry. Of course, solve the equations and tell me. Don't directly tell me. Use those maximum stress equations. Okay. hang on, this is how you will perceive the problems. I'm asking you stress 1, 2, right? So you may want to go to the previous slides where we talked about stress 1, 2 expression. Stress 1, 2. Go here. Here, yeah, this one. So you may want to take a picture of these.
Hocam,
I'm coming. Okay. Now that you take a picture, what is the next step? I'm going to do this. The next step is, hang on. You write the formula. Now you figure out the values of stress X and stress Y. So why don't you tell me, in this particular problem, what is the stress X? Good. And what is stress Y? Good. And what is tau XY in this problem given to me? 0. There is no shear stress that is given to me. Good. Take these values and do it.
hocam, stress.
Good. Good. Very good. I'm sure all of you did it. So stress 1 comes out to be sorry, 2, right? So what was the formula? Stress X plus stress Y divided by 2 plus minus stress X plus stress Y over 2 plus square root of stress X minus stress Y over 2 square plus tau XY square, which is equal to 2 plus 0 over 2 plus 2 minus 0 over 2 plus 0 square. So what is the value? 2. What about stress 2? 0, right? With a minus here. Everyone get it? So 1, 2 plus minus stress 1 and stress 2 like this.
Hocam, also the angle will be 0 for theta p.
Yeah, I know. You are right. I agree with you, but you have to give me a few seconds. So stress Y given to me is 0. Tau XY given to me as 0. Okay. Now give me the value of theta S, everyone. And also give me value of theta P as Mehmet said. Mehmet said theta P equal to. So theta P comes out to be 0 degree and 90. How did you figure? You solved it, no? Good.
So
92. But there's a simple 9270 0 minus 0 infinity.
So it will be same as the decided square, what?
Yeah. Good. Good. This is the square. But give me the value of theta S. Did you figure it out?
Yes, we know.
So it comes out to be. Why my mobile screen? What happened to? I don't know. It's not working. So my notes. So our students are not telling me, so I will do it.
It will be infinity.
Minus what did you say? You said 90 or something like that. Sure? No, it will not be that. Theta minus stress X minus stress Y over 2 tau XY. Now give me theta S equal to tan inverse of minus infinity, right? Which will come out to be? नहीं, ये तो 2 theta S है ना? So theta S will come out to be plus minus जो भी whatever 45. Okay.
What's that mean trigonometry part?
Huh?
For tan inverse minus infinity values.
So that's fine.
So it,
Tan inverse infinity is 90, na?
yeah, absolutely.
Was fine.
So.
Okay, so 90 and 270 means 45 and
135.
Yeah, absolutely.
130. Thank you. So done. Now give me the final squares. Now if this object has to break, this object has to break, how would it break? So now give me the value of tau max. Tau max, how much? Only one. Did you double check? Whatever. Okay. Now I will go and I will start making the squares. Okay, what will be your given square? What is the value? 2 and 2. This will be 2. This will be 0, 0, no shear stress. Then I have 9. Now you have to make it at 45 and 135. So this will be this is your x. Possibly, I don't know. We will double check. Y. You might be right. I don't know. No, but 45 or minus 45, what difference would it make? No? The direction of shear stress. You are right. Okay, we will think about it. Na?
So, previously we said that stress 1 or stress 2 was equal to stress x prime. Stress y prime. What does that actually mean?
That actually means that I'm trying to find the stress x prime at a particular theta p, which subsequently means I'm finding stress 1. I will come to your desk to explain it further. I understand that probably it's not clear. So this becomes. What did you say, Hafat? It should be clockwise. Okay, possibly. So what is the value of? Okay, you can put a negative. Look, I made this problem out of my head. So possibly with a negative, I don't know. You have to double check. What will be this one? Negative?
This should be positive.
No, but why? One is minus 45, then other is minus 130. Oh, minus 45 plus 90. Then it will be positive 45. No? I don't know. Just double check yourself. Whatever. Whatever. I don't know. Whatever. So now you will just give me the value of tau max, 1 megapascal. So one will have, now I don't know whether positive value exists at positive 45 or negative 45. I don't know. You have to double check yourself. How would you double check? How would you double check? Double check with this one. So tau x prime, y prime, that's why I usually like the transformation. Because transformation is, so minus stress x minus stress y over 2. You have to, I don't know. You already did it?
No, but I can understand that.
Plus tau x y cos theta. Okay, I will listen to you because probably you're right. Tell me. How did you figure?
Like when we separate the layers, we separate the forces. So if we take a positive 45-degree angle, it's like that. Forces will be like this, and it's going to be upward.
Okay.
It's going to be positive, negative. It's going to be in that direction, so it's going to be like that.
Tell me the direction of arrows then. Just help me. This is
Both angles are positive.
Yeah. 45 and 135.
Yeah, this,
I don't know, just double check, gentlemen. I have
we have double check.
positive 45. But my question is, what difference would it make? I keep on asking the same question. What difference would it make actually? You're talking about the same planes, this one or that one or that one or that one. Acha, okay. So why don't you give me 45 here? And put the value of, give me tau x prime y prime quickly. But you can do it. Huh?
You get it error.
Minus or positive? Okay. So this means this is your x prime, this is your, okay. Then this is your y prime. Huh? Oh, come on. This is your y prime and this is your, I don't know. Now, all of you told me -1 megapascal at 45. So minus means clockwise at the, so let me use a nice beautiful red color today. Okay, and this will be anti-clockwise. I know I have students who are saying, why on earth do you keep using these transformations? Because I love them. Transformation equations are the best. You just put the thetas and you get the stresses. If I tell you, use the stress 1,2 formula or the maximum shear stress formula, you will find them, but at what theta p theta as they exist, you will keep on struggling in exams. So use this. Did you understand this question or you are getting confused? Tell me.
Hocam, why we said 45 and 135?
They took a tan inverse using a calculator.
But when we do the tan inverse, we get -45 and 45.
Doesn't matter. Doesn't matter. Look. If you get a -45, then you are getting this plane. If you're getting positive 45, you're getting this plane. If you're getting positive 135, you're getting this plane. They in the exam do 45 and 135. You in the exam do -45 and 45. You will all make the same elements. Nothing will happen.
But hocam, when we doing -45 angle, the x prime and y prime directions will be changed.
Nothing will change. Nothing will change. If you
If we turn
okay, then this will be your x prime, na? That's fine. Then still you eventually your element will be the same with the same direction of arrow.
Okay.
It's the same thing, na? Okay. Now I will answer Mid's question. Midge, are you with us? Marriage, are you with us? Sorry for replying to you so late. Marriage? No? Can you hear us? Marriage cannot hear us. Okay, let me see Marriage's question. Marriage said, Hocham, could we achieve two answers 70 minus 30 from one equation? The sigma 1-2 equation? Okay, Hocham. The answer to your question is that you can find the stress 1-2 using this. Where is it? Stress 1,2. Where is it? This one. Use this expression and find stress 1,2. Stress 1 with a positive here, stress 2 means negative here. There is another way. That way is, and can you please all listen to me because this is important. If Bahadur and Ghazal can also listen to this part, this is very important. The other way is you use the tan 2 theta p formula, find the two values of theta p, keep them separate, take one value of theta p, take that one value of theta p and put it here, and get the value of stress x prime. That will give you the corresponding principal stress. Done. Then you take the next value of theta p, because you got two theta p's, and you put it in the same equation, you will get the next principal stress. That's one strategy. There is another strategy. You get only one value of theta p, you put it in this stress x prime, Get the value of principal. You take again the same theta p, but this time you substitute here. You will get the next principal stress, but at a plus 90-degree angle. So gentlemen, ladies and gentlemen, you need practice for this. I will again repeat, you are tan 2 theta p equal to 2 tau xy over stress x minus stress y, two values of theta p. You take one value of theta p, you put it in the stress x prime, it will give you the corresponding principal stress. Done. You take the next value of theta p, because there are two theta p's you are getting from tan inverse, right? You take the next value of theta p, you put it again in the same stress x prime. It will give you the next principal stress. Okay.
In the last question that we saw, it was asking for us sigma 1 and sigma 2, so stress 1 and stress 2,
Ha,
right?
ha. Ek minute.
So-
And did we finish
So
the?
it was asking for sigma 1 and sigma 2, right? And
Yeah.
then we had to also find sigma x prime and sigma y prime. Those are equal. Those are the same thing.
Oh, I did not find it, I think. Stress x prime and y prime on the maximum shear stress plane.
So.
Sorry, I did not. Sorry, I forgot to. Good. Thanks for pointing.
Was the last question.
I did not.
Waited there.
I did not. I will do it. Thank you. I will do it. So his question is, why didn't we find stress x prime and y prime on the maximum shear stress plane? Sorry for that. I actually forgot, honestly. So let's do it. So let's do it. Stress x prime at, what is the value of theta s? Students told me +1, +45 and +135. So give me stress x prime, everyone. Oh, come on, you have to give me this value. Thank you, by the way. I completely forgot. I don't know. Double check. Hafaz, one, everyone? Huh? Abu, everyone? Bahadur, Mehmet, Ahmed.
And then we will use 135 and substitute in sigma x prime equation.
Yeah.
X prime. X prime.
Everything, both the
Values will
both the
theta will go in the first equation.
both the theta in the first equation. Just use stress x prime and put these two. Give me. Stress x prime will be +1. And what about 135? I think it should be +1 as well. I don't. Huh? +1.
Yeah.
Okay, then tell me how should I draw the arrows then? Nice and beautiful light blue color here. Boom, 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 and boom. This is so Hussain, stress x prime and y prime means finding the stresses at a particular angle. Huh?
Yeah, x
So-
prime and y prime, right?
The stress x prime, when I say stress x prime and y prime, your immediate question should be at what theta?
Okay.
If I tell you find it at theta s, if
So
I
what are the sigma 1s and sigma 2s? Because previous question.
I will-
wait.
sigma 1 and sigma 2 are the maximum normal stress and the minimum normal stress. That's sigma 1 and 2.
So
Sigma x
what's the relation? What's the relation?
with what?
Because in the previous question,
Hmm.
I noticed that we made equated them.
Equated?
Like we found, let's say,
Got
when
it.
it was 40, 10, and
Got it,
50,
got it, got it.
and
I
we found
equated them.
70, 30.
ठीक हो गया. I will
And then we
answer.
said those are
I will answer
x
again.
prime.
Got it. Stress x prime needs to be found at a particular theta.
Uh-huh.
If you find it at theta p, that becomes either stress 1 or stress 2.
Okay, now I get it.
Sure?
Okay, yeah.
Okay.
So those are the maximum, the way maximum stress.
Or minimum.
Or minimum.
1, 2 means maximum. Okay, everyone. Is this clear or not? It needs a lot of practice, by the way.
Sir, why are we substituting the second angle in the first equation when we want to find the value for y prime?
I will answer this. By the way, our class is pretty much over. I will just answer this question. We have two thetas.
Yes.
Both of one is 45 and one is 135. Why? One plane is like this and another plane is like this.
Yes.
You have two options. You take the theta, you substitute in stress x prime equation. You take the same theta and put it in the stress y prime, because y prime means something 90 degree to x prime. That's one possibility. Other possibility is you take the same stress x prime equation and you put both the thetas into it. One theta and the other theta plus 90. That is 45 plus 90. That will do the job as well. Na? You got stress x prime equation. Na? We were feeling so happy. In fact, you can do this yourself. Take it as a home task. That stress x prime equation that you have, it has thetas. Right? Start putting theta plus 90 into that. You will get the stress y prime equation. You get my point? Sin theta plus 90 or cos theta plus 90 is the same. Cos theta plus 90, I think, will become negative, right? So I think I already told you that these transformation equations and principal stresses and all the maximum shear stress that I just talked about today, transformation equations and principal stresses and maximum shear stress. This is not included for your midterm 2. This is definitely included for your final exam. If you have any questions, please do ask me. If you want to see your midterm 1 graded paper, you can come to my office today at 12:40 or 12:45. Have a good day. Bye-bye. And by the way, I urge you, if you have missed any class of the last week that is included in midterm 2, please go over that recording or come for office hours. Yes.
This transform equations will be not included, but the first class of this week would write the direct stress and moment stress.
Oh, of course.
It will be included.
I just said this is not included. So why would I say that is not included?
Tom, did you take it in both terms? And make sure make sure.
I graded them.
Because I didn't see it on Mitch class.
Yeah, I did not upload there. You may want to come to my office. If you can.
Today, you
Yeah, let's come at 12:45. 12:40, 12:45. It's 30 right now. Right, 12:40. 10 minutes from now. In 10 minutes, I can show you. Easy 29. I am just wrapping everything, and in 10 minutes I will be in my office.
I have a question about this side. So when we tilt it, there will be 45 degrees and 135 degrees. So we find tau max from this equation, and it will be 1 megapascal. And we deciding that from this, I don't know their names, this equation name. What we
Transformation
call
equation.
Transform equation defining the direction, right? And after that, we finding this not shear stresses, normal stresses when we tilt it from this equations, right? So
What is the question?
I'm trying to clarify in my head, Hocam.
I will tell you. I will tell you. Find the principal stress angles using the equation. Take those theta p, put it into stress x prime. Okay. Put the next value of theta p again in the stress x prime. Get the principal stresses. You want to find the maximum shear stress. Find the theta s. Put it into tau x prime y prime.
Okay.
Transformation equations. Or if you don't like the transformation equations, you can use these directly. Stress 1,2 or the equation of tau max. But I just don't like these equations too much because you will always keep on getting confused